I'm Brendan Griffin, and I'm going to present a session on SharePoint Business Continuity Management with SQL Server AlwaysOn, which is a bit of a tongue twister to get the presentation started. So a little bit about me. I'm a senior Premier Field Engineer based at Microsoft in the UK. I was lucky to attend the MCM programme for SharePoint 2010 before it got scrapped. And I've been working with SharePoint since 2004. So basically from SharePoint Portal Server 2003 onwards, I've seen the product evolve, which has been interesting. So what I'd like to talk about today is to initially set off a little bit of a discussion about what high availability and disaster recovery are, just so that we're all on kind of a level ground. I'll then discuss a little bit about what SQL Server AlwaysOn actually is as a technology, and then step through some demonstrations of how high availability and disaster recovery can be achieved using SharePoint and SQL Server AlwaysOn. Now, in terms of high availability, I've got a nice definition of it here. High availability itself is really about protecting the service level agreements and the agreed fault domains. So in terms of service level agreements, a lot of times I have discussions with customers and they say, right, we would like to build a highly available SharePoint farm and we need like 100% availability, which is obviously not realistic. So they say, okay, about 99.999. They never really have a look at the figures behind it. So this slide's quite interesting because as you can see, even if you promise 99.9% availability, which seems pretty realistic, that means you can have less than 9 hours worth of downtime per year, which is obviously quite stringent requirements for availability. So it's quite good when I have discussions with customers about availability requirements to just present them this slide just to kind of set their expectations and what we can achieve. Obviously, now that Microsoft are in the field of hosting SharePoint themselves, using Office 365, we can use the, I guess, example of the SLA that we have, which is 99.9% availability. Even at 99% availability, you can see you can have nearly 4 days worth of downtime. Now, fault domains, this is an interesting concept. This is a group of physical or virtual infrastructure with a common configuration that share a single point of failure. But just to give you some examples, that could be something as simple as a PSU in a server. It could be a rack, it could be a network card. Essentially, it's the component that, if it fails, could bring the environment down. Now, what I've got here is an example of a SharePoint environment that's been configured in a highly available configuration. Now, we have 2 racks that have been configured that host the servers that have got fully redundant components. And what we've done is we've put together a SharePoint topology that's hosted within these 2 racks with specific components. Now, what I'd like to do is, if you can see it at the back, can you identify any specific problems with this configuration? So we've got 2 racks, we've got multiple servers, redundant disk arrays, and everything seems to be fully highly available. But there's one glaringly obvious, well, hopefully glaringly obvious fault there. Anyone? Yeah. So what we've actually done here is we've provided high availability everywhere, but we've forgotten to span the secure store across 2 racks. Essentially, if we lost the rack on the left, we would also lose the secure store service. So we'd have a mix of service applications that would be available and that wouldn't, which is always something to take into consideration. Now, disaster recovery itself is about recovering the critical operations that enable the business to function in a disaster type scenario, such as a loss of a kind of physical data center. 2 interesting facts. A company that's denied access to their mission critical data for more than 48 hours will likely be out of business within 1 year. And also 1 in 4 businesses never reopen their doors after a disaster, which is pretty shocking figures. You know, a lot of the time customers do find it hard to see the value in disaster recovery, or maybe the kind of maintenance of disaster recovery solutions they've got. I mean, the amount of customers I've worked with that have DR in place that have never tested it can be quite outstanding. We've had instances of customers that do need to invoke DR and they've literally got no documentation, and it really is a disaster. Now, there are 2 key concepts that we talk about when we're talking about disaster recovery, and that is the recovery point objective, commonly known as the RPO, and also the recovery time objective, which is the RTO. Now, in a specific example, a customer may agree with the business that they're allowed a recovery point objective of 1 hour and a recovery time objective of 3 hours. Essentially, what that means is they're willing to lose 1 hour's worth of data and be up and running again within 3 hours. So in terms of high availability, we talk about uptime. In terms of disaster recovery, the two key metrics are the RPO and the RTO. And SharePoint being such a complex product, from a disaster recovery standpoint, there are a multitude of different technologies you can use. Even if you're using kind of Microsoft standard capabilities such as SQL, you've got 3 or 4 options. And if you take into account third-party vendors, there are quite a lot of options out there to hopefully meet any disaster recovery objectives that you've got. Now, how can SQL Server Always On help? So it was introduced in SQL Server 2012, and it's kind of a hybrid between clustering and mirroring. So has anybody used or currently using mirroring? Using clustering? Using Always On, right. Okay. So mirroring was really good, but one of the kind of key issues with mirroring is SharePoint had 2 endpoints to connect to. Now, we did introduce the capability so that if a server failed across, SharePoint could have 2 connection strings. Now, what Always On does slightly differently is it takes the kind of technology behind database mirroring, which works really well, but also wraps that up in clustering too. So instead of failing over and having to worry about 2 connection endpoints, what you essentially have is a virtual IP address that spans the cluster nodes. So when it comes to failover time, for all intents and purposes, SharePoint is completely transparent to SharePoint because it's still connecting to the same server. But instead of connecting to a physical server, it's now connecting to a virtual IP and a virtual server that's part of a cluster. Now, the way it works from a high level are that we place databases into availability groups. So one of the key differences between mirroring and Always On is in mirroring it was done on a per database basis, and failover was also done on a per database basis. Now, some of the issues of that, if you think of service applications such as the user profile service app, it's got more than 1 database, it's actually got 3. So if you did, for whatever the reason, need to fail over the databases for it, using mirroring, it'd be 1 database at a time, which obviously then gives the potential for databases to be out of sync. You know, social tags may be out of sync with the actual user details of the users that have created the tags and such like. But what we can do with Always On is create an availability group and specify databases that reside within that, so that when we fail over, instead of failing over at the database level, we fail over an availability group with the databases contained within. So an example could be you may create an availability group per service application. You may just have 1 availability group for your farm. It really depends on whether you're looking to use it for HA or disaster recovery, as you can see. And I've got a little screenshot there that kind of demonstrates how it looks. So if we've got our very simple SharePoint farm at the top, it connects to the listener, and then it's really the kind of clustering that takes care of routing it to the server that has the active instance of those databases hosted within. Now, it was introduced in SQL Server 2012. In 2014, we introduced some additional capabilities, which is a maximum of 8 secondary copies. So there are 2 configuration options for Always On that really map to high availability or disaster recovery. So we allow up to 2 synchronous copies. By synchronous, we mean we can guarantee no data loss. So when an Always On availability group is configured for synchronous, essentially what happens, a user performs an operation in SharePoint, it routes through to the SharePoint content database. Always On mirrors that information across, but it waits until it's actually been applied to the instance that it's mirrored to. So it's kind of twiddling its thumbs, waits for it to be applied, and only then when it's sure that the replica has applied it, it will then allow the transaction to complete. So there is a small performance penalty, but the advantage is you can guarantee that both databases will be completely in sync, which is important for some specific services within SharePoint. And also, depending on the high availability requirements you've got, it can also guarantee that you'll have little or no data loss. Now, asynchronous is, so anybody that's used mirroring before, is what was previously known as high performance. And essentially, we send the transactions across to the replica, but we don't wait for it to confirm that it's received them. We're literally just throwing the transactions across. If they get received and appended, they do. If not, they don't. Now, one of the disadvantages of that is that there is an opportunity for data loss. So say, for example, you had an availability group configured for asynchronous, and you did a failover. There is a chance that when you failed over, that you will not be at the same level of data that you had on the primary replica. So asynchronous is generally used for disaster recovery because it's also more performant over kind of WAN links. Now you can see there we've got 2 or 8, so what that actually means is 3 or 9, because you've got the primary replica and then at least 2 copies for synchronous, and 8 if for whatever reason you needed 8 additional copies of the database too. So you can mix and match those 2 together depending on your requirements. Now from a SharePoint support perspective, all databases support synchronous replicas for high availability. One of the kind of key points that we do make is that we don't recommend using synchronous replicas for the usage database. The reason for that is it's quite a high throughput database, so it could potentially have a performance impact on the other databases being replicated. And also in most cases, customers don't really use the usage database. If for any reason it's kind of critical to your business, maybe use it for reporting purposes, then sure, it's supported. But if you do have the option, we'd recommend not to. In the case you did have to fail over the databases to a replica and you lost the usage database, it's easy enough to provision a new database. Or what you could actually do is simply restore the usage database from a previous backup, maybe from the evening before. There are no issues with kind of synchronization in that respect. We kind of fully support you restoring a backup even from kind of 6 months ago. I'd probably try to get it excluded. Unless it's critical to the business, which I've never seen yet, I would just exclude it because essentially it's a throwaway database. Now when we're looking at disaster recovery, so this is configuring always on with asynchronous, we've got a slightly different support stance, and there are a number of databases that we don't support. Some of these are pretty clear. So the admin and config database, we don't support asynchronous. Obviously the reason for that is if you are doing disaster recovery, you need to mirror to another farm, and we don't support copying a configuration database over to a separate farm. Some of the others include search, usage, and the user profile sync. So the user profile is a bit of a strange service application. So we support it for the profile and social database, but we don't support it for the sync, which is not really that much of a big issue because we can re-provision the service application and re-provision a sync database. The only thing that we would need to do afterwards is reconfigure any connections that we've got to AD and any connection filters. And last but not least, the state database. For obvious reasons, it's still a state. And I've got a link there that kind of steps through each of the SharePoint databases and gives some insight into the various different options for high availability. And one of the key questions when we talk to customers about Always On is how many Always On availability groups do you need for your environment? And as with any good consultant, standard response, it really depends. It depends on what you're looking to achieve. Now, for my kind of test rigs, and demonstration environments that I'm using today, I've created 4 availability groups. And they're split as follows. So I've got a configuration availability group, and that contains the config DB and also the central admin content database. I then have a separate that's configured for content databases, and then I've split service applications between 2. So I have one for synchronous, so for the service application databases for synchronous replicas, and one for sync and async. So there are some service applications that support the 2. And the reason for this is that in my particular environment, I'll be using Always On for high availability and disaster recovery. If you're just using Always On for HA, you could really get away with one availability group to do things. But if you're looking at disaster recovery too, you need to be mindful of splitting the groups up.
I get what you're saying, but from a very simple mind point of view, the whole point of it is that these servers,
Yep.
the database is here, something goes wrong, it's going to fail over to your other server.
Yep.
So why would you split them into availability groups? Because they all need to go over, right?
Yeah. The reason is disaster recovery. So for disaster recovery, we don't support synchronous for everything, so it makes sense to split it up because we need to add a replica in. Yeah. Yeah. So, well, a group contains synchronous and asynchronous, but it makes sense to split them if you're doing disaster recovery too. If you were just using it for high availability, you could just place everything in one big availability group. Yeah, you could just use one. But if you're doing disaster recovery, it makes sense to split it up because of the different database types. Because you wouldn't want to fail over a database that doesn't support synchronous to a disaster recovery site. So the only way to actually force that is to split them into separate groups.
You'd want to anyway, because you're in a disaster, right?
Yeah, but disaster, we don't support all of the databases being synchronized across. As you'll see later on, for example, search, which we don't support. So to make sure that what you do fail across is what's supported, we split up into separate groups. Now, one of the key prerequisites for AlwaysOn, as I've mentioned, is clustering. So there are various things to take into account for this. Every availability group that we create has a separate IP address and also a virtual name. Other considerations that we need to have, depending on the nodes that we have in the cluster. So in a very basic configuration, we may just have 2 nodes, active and passive, but we may decide to go for something that's a little bit more complex, maybe with 3 or 4 nodes. For example, 1 node might be responsible for an availability group, just for kind of higher throughput. And we need to think about things such as a file share witness. So in a clustering example, it needs to form a quorum. So it makes sense to have an odd number of nodes. And the way that we can achieve that is to use a file share witness. Essentially, if a server can see the file share, then it can be online. If it can't, then it's presumably lost quorum and it fails over. The other thing we need to think about is Active Directory permissions. So for any user that's creating AlwaysOn availability groups, they need the ability to create a computer object in AD. So for each availability group, we create a computer, and also read all properties within Active Directory too. Now, as I've just kind of touched on Quorum, more than half of the voting nodes need to be online for the cluster to be healthy. So for example, if we have a 2-node cluster and one of them's offline, that essentially means the cluster will shut down. It wouldn't generally run with 1 node. So one of the recommendations that we have for that is to configure a witness. The second recommendation that we have is to exclude nodes that are hosted in a disaster recovery site from voting. And the reason is, generally a DR site would be across a WAN link. And obviously if you lost the WAN link, that could affect the vote configuration for the cluster. So in this screenshot here, you can see within the configuration, you can literally select which server should have a vote to decide whether the cluster is available. So as I touched upon, we recommend using a file share witness if you have an even number of voting nodes to prevent a tie. The Windows Server 2012 provided a feature called Dynamic Quorum, which provides additional intelligence. Essentially, when servers go down, fail over, for whatever reason, their votes are removed from them. So if we, for example, had a 5-node cluster, kind of prior to 2012, if a server failed, its vote would still remain. So there is a chance that the cluster would fail if there were less than 2 servers. Now with 2012 Dynamic Quorum, as a server fails, it actually loses its vote. So you can actually have a cluster that fails that only has actually 1 active server running, which is pretty cool. If you're using server 2012 R2, we recommend you always configure a witness. So previously we've said configure a witness if you've got an even number to prevent a tie. But if you've got R2, what it'll actually do is it'll dynamically manage the vote for the file share witness. So if you've got an even number of nodes, it will use that vote. If you have an odd number, it won't. So it'll dynamically decide whether that vote should be taken into consideration or not. So what I'll do now is a demonstration where I'll step through actually creating a failover cluster in preparation for enabling SQL Server AlwaysOn. So if we go to Add Roles and Features, choose my SQL Server, which is SQL 1, and then I'll select the failover clustering feature. That should run through the wizard, install all the prerequisites, and get the binaries ready for configuration. Right, so now we've got the cluster service installed, we actually then need to create the cluster. And what we'll do to save time is the second SQL node, failover clustering, has already been installed. So once we've done that, what we then need to do is to go into the configuration for the failover cluster and select Create Cluster. And then once we've selected that, choose the nodes that will be present within it. So in my case, we have SQL 1 and SQL 2. We'll select the run the validation test, which will just make sure that all of the prerequisites are okay and there are not any issues with the configuration. And now that's complete. If we look at failover cluster manager, after we've looked at the report, what we should then see is the cluster has been created. and the SQL 1 and SQL 2 nodes are now available and configured within it. So I have to give the cluster a name. Now this is actually just used for cluster connectivity rather than anything to do with SharePoint. I'll be original and call it AlwaysOn, and then we need to configure an IP address. Now this cluster name will only be used for connecting for configuration and monitoring purposes. So I've given it an IP address, given it a virtual name, and then the cluster configuration wizard will do the necessary configuration. Now once that's complete, we can see we've got our 2 nodes. We can see how many verts each node have got and the current vert that's been assigned. So now we need to go into SQL, to go to AlwaysOn, have a look around. And configure the quorum. So it doesn't do this by default, so as we've got 2 nodes, I'm going to configure a quorum. And unlike a normal cluster where you'd use a shared disk resource, I'm just going to use a file share. So all I've done is I've created a share on the domain controller that both servers have read and write access to, and point them towards that, and that's used as part of the quorum configuration. In a traditional cluster you'd have shared storage, but for AlwaysOn we don't actually require shared storage, so that's the option that we'd use. So at the end, what we do have is SQL 1 and SQL 2 that have been added to a failover cluster, and they've been configured with a file share witness of DC1 / file share. So what do we need to do next? Well, the next steps are to enable SQL Server AlwaysOn on each node, obviously after SQL's been installed, create the relevant availability groups, configure SharePoint, and then test failover just to ensure that everything's working as we expect. So in terms of the first step, this is pretty simple to do. All we need to do is to go into SQL Server Configuration Manager, and if we go into the SQL service itself and look at the properties, you'll notice there's a little tab called AlwaysOn High Availability. All we have to do is put a little tick into this box and then restart the service. Now if you're running in a configuration where SharePoint's live, then obviously you need to do something like this out of hours. But obviously my test environment's not got any users apart from me, so it's not an issue. So once the service is restarted, we're good to go. Obviously we then repeat that process on SQL 2 so that it was then registered to use that. So the next step is to create the SQL availability groups. And I'll do the first one initially through the GUI, and then I'll script the rest. So we go to the AlwaysOn High Availability tab, and there's a nice wizard that will take us through each step. So the first availability group I'll create, I'll call spconfig, and I'll select the admin content and config.db. We then need to select which nodes participate, so SQL 1's by default because that's where the databases reside, and I've added SQL 2 and selected automatic failover. What I then need to do is to configure a listener for it, because each availability group needs a separate DNS name and obviously IP address. So I'll call it spconfig. Give it a port. I'll just stick to the standard port. You could use a different port if required for security reasons, and then assign an IP address to it. And what the wizard will then do is take care of creating that in the background for me. Now, to get the databases across from SQL 1 to SQL 2, what the wizard will actually do is if you provide it with a file share that both servers have got access to, it'll take a backup of the database, store it in the file share, and then get the second instance, so the second server, SQL 2, to actually perform the restore. So it automates everything for you. One of the nice things when you get to the end of the wizard, there's a little script button that you can press, and it'll give you a script for it. So if you wanted to do an automated build out, you could just go through the GUI and then get the script and then execute the script rather than using the wizard, and that's good for kind of rebuilding environments. So now we can see our availability groups listed, spconfig, and we can see the replicas. So SQL 1's our primary and SQL 2's our secondary. We can see the listings that we've got and also the databases that are stored within it. And what we'll do now is I've scripted out the other 3 availability groups that I'm going to create. You can see that's automated the configuration. We've got a single content database from our test farm, and we've also got another listener for it. I'll do the same again for the sync and then the async. There we go, we're nearly there now. And there we go. We've now got all of our availability groups created and ready to go. And if we look on SQL 2 and do a refresh, what we should now see is all of the databases, and we can see their current status. So we can see that they're synchronized, which means that they're in sync with the primary. So if we did have to fail over for whatever the reason, there would be zero data loss.
Can I ask a question?
Sure.
A bit of a strange question. Say you've got SQL 1, SQL 2.
Yep.
And your infrastructure team has actually built SQL 2 wrong and it's got less disk space.
Yeah.
But you're running with availability.
Yes.
And the failure, the mirrored, if you like, fails because two passive nodes run out of disk space.
Yeah.
Obviously, will the databases on the active node stop responding because they can't mirror?
No. Even if it's synchronous, it'll just force to data loss. Yeah.
Stop, but will they still be operational is the question.
Yeah, SQL 1 would still be operational. It just means the data wouldn't be synchronized across the SQL 2. I've got a few top tips if you are looking to use AlwaysOn. So within SQL there's an option for backup preferences, and if you've got an active passive SQL 1, SQL 2 style configuration, obviously there's a chance that databases availability groups may fail over between the two. Now, to ensure that backups are stored in a consistent location, because you're never sure where they are, and to save you logging onto two servers, what you can actually do is use backup preferences. And what this does is it allows you to configure which server backups are taken from. So sometimes backups can have a performance impact. So rather than taking the backups from the primary server, you may decide that you prefer to take the backups from a secondary server. Now, the weird thing about this, I remember when I saw the feature and thought, this is really cool. So I can basically get backups configured so they'll only be taken on the secondary box. So I set up a backup, I run it, and it executed on the primary box. Now, the reason for that is there's actually a function that you need to execute. So if you are configuring backups, you need to configure them on each node within the cluster. Execute this function first, and this function will basically say, can this server take the backups? If it returns a 1, you then perform the backup. If it returns a 0, you fail, and you don't perform the backup. So although you can select, it basically controls the logic rather than actually making sure that backups are taken on the correct server, if that makes sense. As I touched on earlier on, configure SQL to store backups in a common file share. The last thing that you want is needing to restore a database or get a backup for any reason, having to log on to both nodes and check the backup directories to see where they are. It makes sense to have a file share somewhere to store the SQL backups on, so you've got one central consistent place to go to get SQL backups for all of the databases. In terms of firewall ports, there are two that you need to be aware of. 5022 is required for the AlwaysOn endpoints, which is the same as database mirroring. If you use the default configuration, 1433 for SQL connectivity. If you're more security-minded, a bit of security through obscurity, and you do decide to use a different port number, then what you'll need to do is configure a SQL alias on each one of the SharePoint servers to essentially point it to the correct availability group and the port that availability group's configured to. So in this specific case here, may not be too clear, I've created an alias called SP content, and it connects to SP content, but it connects to it on a very specific port. So what's next? So we've done all the other stuff. We'll actually get to see a little bit of SharePoint now.
Sorry, just on that alias, is that the listener?
Yeah. So all you do is what you'd need to do. So if you had, say, for example, 4 availability groups, you'd configure them all to use a completely different port. What you'd need to do on every SharePoint server is add an alias that pointed the alias name to the alias, but then you use the specific port number that you'd used, because it doesn't work with the browser service. Yeah, you map into your availability set, but because it's using a non-standard port, you'd need to specify that different port. which is fun. So the next thing that we need to do is actually tell SharePoint about these databases. At the minute, everything's working because my SharePoint farm was configured to speak to SQL 1. Even though we've got AlwaysOn configured, SQL 1 is still responding and still houses those databases. If for whatever reason now I failed of everything to SQL 2, SharePoint would fall over in a heap because it'd be trying to connect to SQL 1. So the first thing that we need to do once AlwaysOn's been set up is to tell SharePoint about these availability groups so that essentially it can update the connection strings. So what I'll do first is execute the get_sp database command, and what we can see there is that all databases are connecting to the server named SQL. Then got two commands to run, one for each database, where you specify the availability group name, the database, and a file share. Now the interesting thing is that the commands themselves can take care of actually doing as part of the configuration I did, I selected all of the databases and got the availability group wizard to do the backups and restores. If for whatever reason you want to do that directly from SharePoint, you can use these commands as well. The only thing you need to be aware of is the availability group needs to be connected first. I guess an example of this would be, say you add a new content database, you could just use this command simply to add it to an existing AlwaysOn availability group. Now once we've done that, it'll do the backup and then the restore, add those databases to the availability group, which are already there. But the most important thing, well, the only thing that we're actually using it for, is to update the connection string within SharePoint. So if we look now, we can see for those two databases, the connection string is now spconfig instead of SQL. There's another command that we've got called get availability group status that can tell us how the current availability groups are. So as a SharePoint admin, you could maybe have some automated PowerShell that runs this just to check the health and configuration. Now the next thing we need to do is to test failover. Now what I've done kind of separate to this that I didn't do there is I've also added the content databases into an availability group and updated SharePoint 2. So when it comes to failover time, what I'm going to do is failover spconfig. I'll do it gracefully, just using the GUI, but obviously if SQL 1 as a server shut down or malfunction, this would happen automatically. We select the server to failover 2. We've only got one because there are only two in the cluster. Connect to it, and then hit finish, and then it'll take care of failing over any databases within that group across to the second instance that we've selected. 9 times out of 10 you're not going to have this luxury because it likely would have failed, but for purposes of a demo I'll do it manually. And then I'll do the same for SP content 2. So this is the one I already updated the listener for within SharePoint, but didn't do within the demonstration. And I'll take a few seconds just to fail across. And we can see now SQL 1's a secondary and SQL 2's listed as a primary. If we go to my test site and basically do a refresh, we can now see the site's still working even though we're not actually running on the original SQL server. And again, if we go into central admin, and I'll just go to create a site collection or do something, see that works as expected. So this is how the demo environment looked at the beginning. We had a single SharePoint box and a single SQL server. Essentially, SharePoint was speaking to SQL 1. Now what we've got at the end is SharePoint now is speaking to the AlwaysOn availability listeners, which means that requests could hit either SQL 1 or SQL 2, depending which is the primary and the secondary, and it's failover clustering that's facilitating the failover between the two nodes. Yeah, so each availability group has a separate listener, yeah. And then the cluster takes care when it receives a request to route it to the correct server that's got the live active instance.
So in your example there, you've got two live servers in effect,
yeah.
all the availability groups. So that's almost like you get active forms, isn't it?
Yeah, so one of the recommendations we usually make to customers in this case, there's no point in having a SQL server sat there twiddling its thumbs. What you may as well do, so in this example, you've got 4 availability groups. Have SQL 1 have 2 as a primary, and have SQL 2 have 2 as well. So you essentially run an active-active, and then, for example, if SQL 1 failed, it would just be a case of SQL 2 would then have to run 4.
Affect your licensing, though, no? Does it not matter? Do you still pay for the inactive node if it's passive? Because these are enterprise only.
Yeah, it's an enterprise-only feature, so...
You're recommending, let's have loads of...
Hey, I'd have to pay for it, so it's fine. It's fine by me. I know nothing about licensing. I try to avoid it like the plague. Yeah, it really is. So, yeah, I'm not actually... But I can look into that if anybody's interested.
Rather than ignorance.
Yeah, I would. Let somebody else deal with it. Anything to do with licensing.
That's it,
Now, I have another top tip, which is there's a property for each database within SharePoint that was introduced, I can't remember, probably a year or 2 ago, called the multi-subnet failover. Now, it's recommended for each content database that you enable this. The reason being is I'll try to explain it in a simple way as possible. If you have AlwaysOn configured in a disaster recovery configuration where you've maybe got HA in your primary site and then you've got asynchronous going across to your disaster recovery site, now those servers are going to be on different subnets, so each listener will have 2 IP addresses, one for the live site and one for the DR, because unless you're using a spanned VLAN, the chances are there'll be completely different subnets. Now, without this configuration setting configured, what SharePoint will try to do is it'll try to connect to all of the endpoints that are registered. So it'll connect to the first address and then the second. Now, it could connect to DR first and then to your live production site, which can cause connectivity issues. If you enable multi-subnet failover, what it essentially does is it still connects to all of the IP addresses, but instead of doing it serial, it does it in a parallel fashion, so it'll connect to them all at the same time.
Because we had an issue when we had this installed on our premise that we can only connect via Management Studio to the availability group when we're using the connection string multi-subnet failover true.
Yeah.
Connection.
Yeah.
And this will stop us having to do that, right?
Yeah, well, the problem is it'll try to connect to every IP address, but it'll do it in order. And what can happen sometimes is it takes longer for it to actually connect to the active address than the timeout, in which case it'll stop you from connecting. If you enable this property, it'll connect in parallel to all addresses, and it's the first to respond. So this little piece of PowerShell you execute will set that property. We recommend doing that after you've configured AlwaysOn. Now, onto disaster recovery. A very complex area, partly because of SharePoint's funky way that it does a lot of things. It really depends on the service applications that you're looking to use. And our recommendation for disaster recovery is to use asynchronous commit. The reason for that is generally disaster recovery will be hosted in a secondary data center that's across a WAN link that's latent. If you use synchronous, you could cause performance issues because essentially every operation that's performed has to go across this WAN link, which is latent, maybe not particularly performant, wait for the server to say, yep, I've committed that, before it then returns the request back to the user. And I saw a great example of this recently where a customer was doing this across links and it was taking like 15 or 20 minutes to create a site collection. It was absolutely ridiculous. I don't think they'd ever, I'd never seen performance issues like it. And I kind of peeled away and looked at the configuration and said, why using synchronous across sites when they couldn't guarantee the latency or the bandwidth that they'd have? It was killing a lot of extensive operations, so things like creating site collections were just taking forever. Anything that had to move a lot of data around, like maybe uploading a 50 or 100 meg document, was a massive performance killer. So for disaster recovery, asynchronous is the way. Now there is a potential for data loss, but the advantage is you're not going to harm the performance of your production environment by it. There are 2 failover processes. Obviously, if you do have an option to failover to DR, you'd like it to be planned and be able to know about disasters in the future. Unfortunately, in most cases, they're unplanned, in which case it's a slightly different approach that you need to take because you've not got the kind of luxury of some of the options. Now, search, as with a lot of things in SharePoint, is very special. So unlike other service applications like the user profile service app, search stores information within SQL databases and also data within the flat file indexes that sit on servers within the SharePoint farm. Now what this means from an availability perspective is that if you do fail over to a disaster recovery site, sure you can fail over the databases, but what about these index files that sit on the other environment? Now unfortunately you can't just take a normal Windows backup and copy between one and the other. So the options are, which are not great, are either to use the out-of-the-box backup and restore tooling, which in addition to backing up the SQL databases, it will also back up the index. Problem with that is if you've got a very large environment, backup could take a long time to execute and could potentially affect the performance of the production farm. The other option that you've got is to attach the search admin database to the disaster recovery farm and provision new databases for the others. But the downside to that is that you need to perform a full crawl. Other options I've seen is having a completely separate instance of search provisioned in DR and get DR to crawl live. Now, one of the issues with that wasn't so much of an issue in 2010, but in 2013, a lot of the data on usage analytics is actually stored within the index. So if you did the dual crawl approach, you'd lose usage analytics, which for a lot of customers is quite an important piece of functionality. So there are 2 or 3 options for search. It's really kind of choosing like the better of the 2 or 3 evils, to be completely honest. Some standard guidance. So if you do have a disaster recovery configuration, you obviously need a separate SharePoint farm. You can't share config databases across. We don't support stretched farms, so you would have essentially a second SQL instance and a second SharePoint farm, whether that's the same spec or it's slightly slimmed down depending on any performance targets that you've got. Now, what you need to do is make sure that any customizations that you've got are deployed to both environments. So if you have a change request to deploy some web parts, you need to make sure that that also gets done on DR, because at failover time, if those aren't available, you get a horrible end-user experience when things are nice and broken. The other piece to be aware of is that any farm and web application scope features would also need to be deployed to DR. And also any farm-wide configuration changes are replicated to the disaster recovery farm. So even simple things like outbound email, you know, the from address for emails and such like, you need to have a process that captures whenever that's changed in live and copy that across to disaster recovery. It would be absolutely fantastic if we had a nice little tool out the box that would back up all of this and then restore. 2010 did introduce a configuration-only backup, but not all service applications and features make use of it. So that's not really ideal. I see a lot of customers put together custom PowerShell scripts, and there are a few I've seen out there on the internet, TechNet script gallery, that do a fairly reasonable job of backing up settings. But again, this is one other thing just to kind of take into account. Now, there are some service applications that don't have a database, which means at failover time, you've not got to worry about them. But the one thing you do need to worry about is the configuration settings. So if you've changed the configuration settings for any of these service applications, for whatever reason, be it performance or security, you need to make sure that those settings are copied across to the disaster recovery environment too, so that failover users get a kind of similar experience. So what is a high-level process for configuring disaster recovery? So if we take our current configuration that we've got and we want to enable it for DR, high-level steps are as follows. We'd add a third node to the cluster in the DR site. So if this is a SQL cluster that we created. Configure AlwaysOn asynchronous replica, which we actually did when I configured the 4 groups. Provision a disaster recovery SharePoint farm, and then create a failover plan. Although, to be honest, you'd probably create the failover plan first. So high-level steps when it comes to recovery. The first one is to bring the DR nodes online, if they're already not, and set up high availability if required. So this is a really good point, actually, that some customers have this amazing HA disaster recovery, but they don't have HA in the DR site. So in the very unfortunate chance that they do have to invoke DR and fail over to their DR site, if they lost the component from the DR farm, there is always a chance that could bring it down. So in terms of SQL, it could be provision another SQL server to ensure that the databases are available should the primary SQL server fail. From a service application perspective, depending on the approach that you use for disaster recovery, so there are generally 2. 1, have the service applications provisioned using the replica database, or the approach that I prefer is to have the databases replicated across, don't have the service applications, and just have a PowerShell script to run at failover that hooks everything up. The reason for that is I'm a little bit anal, and if you don't do it that way, you get an event log and ULS logs that are full of rubbish because it can't connect to the database. And a similar approach with the content databases. What I generally do is have the web application there created and ready to go, don't have any databases attached, and then at failover time just have a PowerShell script that grabs all of the content databases and attaches them to the web app. And then last but not least, validate the configuration. So presumably you're going to need to make some DNS changes to force it to connect through the disaster recovery site and perform some testing to make sure that the farm works and it's performant and there aren't any issues that will likely trip you up at failover. So this demo will take you through configuring and testing disaster recovery for SharePoint. So the first thing that we'll do is on our SQL 3, which is a new node, we will install failover cluster. So what I'll do initially is I'll connect to the cluster that we created AlwaysOn, and then I'll add node. So, sorry, I already had failover clustering installed. SQL 3, which is the box that I'm on, so I want to add that to the cluster. I'm in a rush, so we won't bother doing the tests. And at the end of this, that server is now a part of that cluster. It's not actually performing any operations, so you can't physically fail over any databases to it, but it's the first step in getting it enabled and ready for AlwaysOn failover. Now at this point, what I'd probably do is remove the vote from SQL 3. Because it's in a disaster recovery site, I don't want it having a vote because of network latency and such like. The next thing I need to do is to go into the SQL Server service, as you saw a few minutes ago, enable AlwaysOn, and then quickly restart the service. It's funny, these demonstrations are recorded, but I still worry they'll fail. Years and years of demos going wrong. So. Now what we'll see, so if I go into SP content, we'll see we've got our two nodes and our single database. What we'll do now is add an additional replica, and I'll add in SQL 3. So what we have to do is connect to any secondaries that we've got. So I'm going to need to connect to SQL 2. Then add a replica, and I'll choose SQL 3. Now the default when you add a replica is to do asynchronous, so we don't actually need to change the configuration. If it needed to be synchronous, we'd need to put a tick in there. We then give it the file share to do the backup and restore to, and complete the wizard. At which point, that server now is a part of that AlwaysOn availability group, so in theory databases can be failed over to it for disaster recovery purposes. No, it doesn't, because the configuration that we've got, it will fail over to 2. It will never fail over to 3. You can only do a manual failover to 3 because it's not configured for automatic failover because it's using synchronous. Okay. Yeah, so if you select asynchronous, it doesn't allow automatic failover capabilities. Because the last thing you'd want is you had a failure in your primary site, and for whatever reason it tried to fail over to DR, because that could break a lot of things and cause performance problems. So default configuration when you add is asynchronous, which doesn't allow automatic failover. If I did it as asynchronous, you've got a little tick box to allow automatic failover, which I did for SQL 2, but for SQL 3, there's a couple of things. One, it's asynchronous. So for asynchronous, you can never do it. It needs to be a manual failover for asynchronous because there's a chance of data loss, and it needs to be your decision as to whether you take that. But for synchronous, we allow automatic failover between 2 nodes. So although you can have the primary in 2 copies, we only allow automatic failover between 2.
Also, a quick question. Is there a system table that tells you the history of the failovers?
Yeah, there are quite a few DMVs for AlwaysOn. There's probably about 20 or 30 that you can use just to check the kind of status and history and any issues that you've had. And what we'll do is then for the sync-async availability group, there's got databases that support asynchronous failover. I'll also add a replica to these 2. Using exactly the same approach. Because for disaster recovery, it's not going to support the SP config because we can't fill up the config DB. It's going to support the content because that supports asynchronous, and it will support the sync-async because that contains databases that support both synchronous and asynchronous. So there we've got 2 secondaries. And then the 3 databases. So all I'm filling over is manage metadata and the user profile service app, minus the sync DB, which I will recreate at failover time. Now what we'll do is we will now failover. And if you see here, when it comes to failover time, you've got a couple of options. So I could failover to SQL 2 or SQL 3, but SQL 3's got this big exclamation mark to warn me that there is a lot of potential for data loss. Put another tick in the box just to say I'm sure. Then connect to SQL 3 and then complete the wizard. Which is known as a forced failover. So if I fail over this one too, this is just for the service applications. You just have to force it from SQL 3. Yeah, because SQL 3 still got SQL installed. It can't connect to 1 and 2. You just get SQL 3 to grab it. Right, so the next thing that we'll do, I'll show you my web application I've created. I've created with a slightly different URL to live, which is DR. And you can see we don't have any databases attached. And I'll just do a refresh just to show you that there's not any magic going on. And also, if we have a look at the list of service applications, we've literally got the very basic just SharePoint installed. What I've then got is a script. Script does a couple of things. First thing it does is it attaches the content database that's been failed over to the web application. The second thing that it does, well, it's kind of second and third, is to create a new instance of the managed metadata service app and the user profile service app, pointing it to the databases that have been failed over. The one exception to that is the user profile service, where I provision a new sync database because that's not supported for failover. So the manual step for this you would need to do afterwards is to reconfigure any sync connections that you've got, because that wouldn't be brought across because you've lost the sync DB.
Sorry,
Sure?
it was relatively fast there, your amount of DB you want. I'm assuming these databases are relatively small.
Yeah, this is like 3-4 meg databases.
What sort of time frame would you say for a production system to fail over?
I wouldn't like to commit to anything, to be honest. You should hopefully be talking about minutes rather than hours. I mean, you could attach content databases kind of synchronously, so have multiple PowerShell windows rather than kind of doing it one after the other. That'd be another way. But to be completely honest, the database size, although it has some impact, it's not linear impact. All it essentially, the key thing it has to do is to read the sites table to propagate the config DB. So. Right, so if we now refresh the web application, you'll see our super looking always-on demo site should come to life. And then if we go into, we can actually go into site settings and the site works. And if we look at the service applications now, we should see the user profile service and manage metadata. So if we go into the user profile service app, you can see, hopefully they're very small, we've got our users, so we have actually got some data in there. My test users. So that's come across. The only thing that you need to do is to recreate the synchronization connection to Active Directory, otherwise the user data will become stale. So basically this was the start. Before we configured disaster recovery, we had a single SharePoint box, which obviously would have been a farm in production. 2 SQL nodes configured for AlwaysOn, and using synchronous for that for automatic failover. The end of it, we added SharePoint DR and a third SQL node and configured the 2 AlwaysOn availability groups that support asynchronous to use that. And then we failed across a content database, the managed metadata, and the user profile service application to them. What you also need to take into account is failback. So I've showed you how to get the data across. Now, at some point, your production site will come back online, and you then need to cater for the scenario of, okay, how do you actually get that data back? And that's something else to think about. Now, this is in the cloud track, and I'm kind of about 55 minutes in, and I've got a very little bit about the cloud at the end. So say, for example, you don't have disaster recovery facilities, and you may be looking at using a cloud-hosted provider, such as Azure, to provide DR capabilities. What you could do is you host your SharePoint disaster recovery farm and third SQL cluster node in Azure. Now, there are some considerations for this. The key one being is that you need to have permanent connectivity to Azure from your on-premise environment, so either via a site-to-site VPN or express route, if you've got that configured. You also need to make sure within Azure that you do have supporting services such as Active Directory and DNS, because the last thing you'd want is to fail over to Azure, this brilliant cloud solution, and find out that performance was awful, because all requests essentially for authentication were then coming across the VPN back into on-prem for authentication and DNS lookups and such like. One of the key drawbacks with Azure and AlwaysOn is that it only actually supports one availability group. So if you've got a configurer where so you need to configure it in a way that you're only using one availability group, and that's due to the design of Azure. Essentially, for each cloud service, you can only have one always-on availability group. Hopefully in the future it'll change and it'll be kind of feature parity with on-prem, but for the minute, you've got the choice of one.
So what does that mean in the real world? So you're talking about you've got your HA on-premise.
Yep.
And you can have multiple availability groups there, and then you just have one that will be linking to Azure.
You couldn't. What you'd probably have to do is to split it into two. So you'd have two availability groups on-prem, one that supported synchronous and one that supported asynchronous, and just only fail over the asynchronous to Azure. Yeah, which hopefully in the future it'll change. It'll be feature parity, so you can configure it as you would do on-prem, but at the minute, due to the way that Azure networking works, there is only one. The other point is performance. So premium storage that's just been released provides SSD storage capability, so you get more IOPS and a more kind of on-prem style performance from Azure. And last but not least, I'm cheap, cost. Recommendation would be to keep any SharePoint servers that you've got within your disaster recovery farm shut down until failover. Maybe bring them up if you need to make any configuration changes, but to keep costs down, keep them shut down. Essentially in Azure, all you should need is your SQL box and your AD DNS to be online constantly for replication. Your SharePoint servers could be shut down. Right, perfect timing, bang on an hour. Thanks guys.